So my name's Eric Bergener. I'm a research director at IDC, and I focus on software-defined infrastructure and also flash-based arrays. So those are my two primary areas of interest. What I'm going to talk with you a little bit about today is some of the driving forces in what IDC refers to as the third platform computing environment. Some of the changes this is driving in how we provide compute and also storage services in the modern IT world.
Test.
Is this one on? Yeah, that
There you go, bud.
Maybe. Oh, okay.
Thank you. Sorry about that.
Yeah, I don't know if I'm going to be able to keep that volume up without it. All right. And the clicker. Okay, so first let me set the stage by defining what the third platform computing environment actually means. So we're contrasting this with the client-server model of old, the one people were used to from the 80s and the 90s, where you had basically a single application on a dedicated physical server. What's happened in the new world is there's been a huge move towards virtualization, and server consolidation is happening at a huge rate. In fact, by 2019, 75% of all the IT applications that are running in the industry will be running on virtual infrastructure. At this point, we're at sort of around the 62% range for that. So that'll continue to increase going forward. That environment is allowing people to consolidate what we consider legacy applications, so packaged software, relational databases, that kind of thing, onto a virtual infrastructure. But at the same time, we're also seeing the generation of what we call next-generation applications. And we're going to take a little bit closer look at what those are. But the key on this slide for that is that the I/O profiles and some of the other things that are required of the storage infrastructure in particular in this environment just absolutely can't be met with the technologies that did a great job of meeting performance requirements in the second platform era. So with this mix of applications running in this environment, what we're seeing is significantly more random I/O, a wide variety of block sizes, significant differences in what the peak and the steady state requirements are. So application environments have become significantly more dynamic. And this means that you really can't build a storage infrastructure out of spinning disks and expect to cost effectively meet the storage performance requirements in the new world. So those I/O profiles in this new model are very problematic for classic storage. Another big difference we're seeing is in data growth rates. So we all thought data was growing rapidly when we had to think about dealing with tens of terabytes of data back in the 90s. But now, even medium-sized businesses have to think about, over time, how they're going to be able to manage petabytes of business and be able to do that cost effectively. So managing data growth is actually the top challenge. When we put surveys out about what people view as their biggest storage problems, managing data growth consistently over the last 3 years has been the #1 concern in these environments. And that's clearly a big difference from what you saw in the older model. There are also pressures from the business side. And we're seeing new types of businesses that are very different from the older models that we saw in the 80s and the 90s, and they have very different requirements in terms of customer expectations for response time in particular, but there's also a lot of data growth and retention issues, so there's a lot of changes in this environment in terms of the dynamism of it. And really the bottom line is that the older architectures, both for servers and for storage that were in use in the second platform model, which we view as hardware defined, really just don't provide the agility and the flexibility that you need in this newer environment. And that's really driving the need for a variety of new storage architectures that you've seen appear over the course of the last 5 to 8 years. Not only virtualization and how storage gets handled in that environment, but you see hyper-converged platforms, you see software-only solutions built around scale-out x86 server models, you see all-flash arrays. So those were basically in response to the requirements of third platform computing that could not be effectively handled by the older model. Okay, so let's talk a little bit more about what we term next generation applications. So third platform computing is really built around an application set for mobile computing, social media and business, big data and analytics, and cloud computing. And these are all models that didn't exist 15 years ago in any appreciable manner. They have some significant commonalities, particularly as you contrast them with the second generation applications that were much more static and also tended to often be much more packaged solutions that you would buy from a vendor. We're clearly moving away from that. More application services are moving to the cloud and are being provided on an as-a-service basis, and we clearly think that's the future. So we're moving away from the era of packaged software, which is clearly a second platform technology. But in the data centers, we do still need to support those legacy applications. So we need to provide the environment that can accommodate what they need as well as the dynamism required by the newer environments. So what identifies these next generation applications? These tend to be born on the web kind of applications. They're developed and deployed using very agile methodologies. You need to be able to spin up new capacity, new performance capabilities very rapidly on a project-by-project basis. And the older models for development and for deployment just can't produce the necessary resources fast enough. Think about the difference between how long it took in 1995 when you needed to order a new server to bring up a new application environment and what you do now, which is you go to vCenter and you spin up a new VM, you allocate resources dynamically, and that system can be online literally within a couple of hours. There are also some other significant differences in the application architectures. Many people probably dealt with sort of the HA failover models back in the 80s and the 90s. Applications in that era were built under the assumption that the infrastructure itself would provide resiliency. And the newer application models are not relying on resilient infrastructure. This allows you to actually use commodity hardware in that underlying infrastructure, and with the resiliency built into the applications, you still get the enterprise class reliability and availability that you need in those environments. But it's a very different model, and it lends itself much better to the scale-out, software-defined models that we're seeing really start to come to the fore in these environments. So the point of that slide was just how different the new environments are from the older ones. Okay, so let's talk a little bit about what the need for software-defined is. Well, it's interesting that this model really started back with some of the key players like Google and Amazon in the early 2000s, companies that were looking for a lower-cost approach to provide massively scalable data services to literally millions of clients simultaneously. They built their own environments around x86 servers. They built the software themselves. What we've seen in the last 8 years or so is that model has been taken by a number of companies. Initially, they were startups, but now some of the majors are playing in this game as well. And they're trying to provide some of the same capabilities that caused Google and Amazon, Alibaba to build those infrastructures in the first place. Agility, lower cost, and also everything managed in software so that when you needed to go in and change things, it didn't require any changes to the underlying hardware. It was just a logical reallocation of resources. And sort of an interesting way to think about this is the ability to build servers dynamically and give them the resources you need as you need them. Think about when you walk out to your driveway in the morning, and let's say you've got a sedan in the driveway. You bought that sedan, it's a sedan every day. It does certain things well, it doesn't do other things well. If you want to go off-road, you might go buy a four-wheel drive, but that sedan's not going to be good at that. With virtual computing, it's just like being able to configure dynamically the kind of car you want sitting in your driveway every morning when you walk out there. That's the power of the flexibility that virtual environments bring to the table. So why do we need this kind of agility? Spinning resources up for new projects on a rapid basis and then spinning them down, reallocating those resources back into a pool where they can be easily reused again. This is one of the key reasons people are interested in software-defined infrastructure. Think about how easy it was to apportion CPU resources when VMware first came out with their virtualization solutions and technology, that was one of the key reasons people were interested in that. Well, now that same model is being applied to storage and to networking. And we're actually getting a good ways down that path with the flexibility to configure those things on an as-needed basis. Simplicity. So one of the trends we've seen over the course of the last 5 years is in the storage area in particular, administrative tasks have been migrating from dedicated storage professionals and dedicated storage administration teams to generalists. Those generalists typically had either a virtual management background or an application background. They're not storage guys. And what we've seen with a lot of the vendors is they're building capabilities into the software infrastructure, and these typically are built into the software layer, that will handle a lot of the routine tasks that a virtual administrator wouldn't necessarily know. How do I configure a LUN? How do I allocate and provision storage and provide the right RAID levels? How do I set up DR configurations appropriately? A lot of the tools, a lot of the products don't require that level of capability. They basically ask for how much capacity do you need, tell me the level of protection you require, and then that software will go get the resources it needs and configure that in the back end. And that's clearly where we're headed. There are products on the market today that do that very well, but we think that's going to be something that we actually start to see in a lot of the hardware-defined products driven by the software that runs on them going forward. That's really the only way you're going to be able to deal with the complexity that we have with all of the heterogeneity that you're forced to manage in these environments. You've got VMware and Hyper-V. You've got physical and virtual servers. You've got different application environments. You've got block, file, in some cases object. So there's a lot of complexity. You need an automation layer that can be managed centrally from a software point of view to be able to handle that efficiently. And then, no surprise probably here, but the software-defined model, because it runs on commodity off-the-shelf hardware, is significantly less expensive than proprietary hardware designs of the past. And in fact, what we typically see is there'll be a 50% savings right up front if you configure the same level of capability and capacity in one of these software-defined models built on top of an x86 scale-out architecture versus buying something like, you know, an EMC VNX, something of that nature. So that's a key issue there. And in fact, we're going to take a look at some data here from a recent survey about why people move to these environments in just a minute. So software-defined, briefly, how do we define that? So this is software that provides a persistent storage capability for primary storage and or secondary, and doesn't require any other tools other than it's running on top of an x86 server that has some internal storage. There are 4 basic types of this: block, file, object, and hyperconverged, which is where you co-locate compute and storage resources on the same platform. When people initially look at these architectures, the 2 things they expect to get out of software-defined deployments are lower cost and an architecture that has much more affinity for the kind of applications they want to put on it, which typically tend to be the next generation applications. You know, one of the interesting developments as these scale-out models were developed over the course of the last 8 years was how do you provide the same level of enterprise-class capability in a pure software solution? Okay, you have people that they've got their VMAXs and their VSPs running they've had them for 10, 15 years. One of the key questions they bring to the table is, how can I ensure my data will be safe in this new architecture? And we've come a long way with companies building those kind of capabilities into pure software and running them on these scale-out x86 environments. So on the benefits side, I'm going to kind of split how we talk about this. So first off, we did a survey in August of this year, and it had roughly 400 respondents, and we asked them, so you've deployed software-defined storage. Did you achieve the benefits you expected to achieve? 61% of them did, and here's how the benefits fall out. So you can see reducing OpEx and CapEx, your cost issue, easier management, that's where a lot of this autonomous storage management that I mentioned comes in, and reduced provisioning times is actually part of that as well. And then down there at the bottom, we have the reducing vendor lock-in. So again, these systems are software running on commodity x86 servers. You can buy them from Dell, HP, IBM, or there's other providers of that kind of hardware. And then I just wanted to go back and make the final comment that another key reason people move to these environments is for the agility. So that's always part of the game in this case. Okay, on the trend side, we talked a little bit about storage management migrating to IT generalists. We've talked about autonomous storage management and obviously the need to implement orchestration and automation so that you can continue to manage operations reliably at scale with people that are not dedicated storage administrators. There are still dedicated teams, mostly in larger companies, but what we're seeing happen, if they're not migrating them to generalists, they're offloading those services to the cloud. And in fact, let me make another comment that's not from a data set that's on here, because we have limited time and I couldn't show everything, but a huge change that we're seeing is, if you look at all of the enterprise storage spend in 2019, which will roughly be $50 billion on enterprise storage specifically, over 70% of that will come from cloud-based models. So what's happening is a huge shift from on-premise deployment to cloud-based models. And this is another way that companies are leveraging the resources at their beck and call to be able to manage massive data growth cost effectively. They're not managing those themselves. They're managing 2 service levels, and they're having other people do that work for them. So that is clearly a key trend going forward. A lot of the other documentation that we produce comments frequently on the fact that we think the future is absolutely hybrid cloud. People will move applications to the cloud if they feel that they can, and for those applications that stay in on-premise environments, there'll be a specific reason why they have to keep them there. And that may vary by company type and by industry, but it's sort of the thing of move to the cloud when you can, keep it on-prem if you have to, and this is what we see happening over the next 5 to 10 years. And that has some significant implications also for IT administrators, who are increasingly going to be employed by service and cloud providers over the next decade and less by companies directly. Okay, and then let me make one more comment in closing. So another thing that we track is storage capacity that's deployed in an environment in production. Where does it reside? How much of it is in a SAN versus how much of it is internal storage, and how much of it is considered virtual infrastructure. So you can see the splits right here. Internal, 37%. That is the model that is at the core of what's happening with software-defined storage. x86 servers running internal HDDs or SSDs in this environment. And then you've still got SANs, which are the external storage. And then virtual infrastructure is a split, because you can have shared storage deployed in VMware clusters as an example, or Hyper-V clusters, but you can also be running on some sort of a hyper-converged model as well, which has got internal storage. And again, we're seeing things start to move in that direction. That's not larger in spend today, but over the course of the next 5 to 6 years, there's going to be a crossover point there. And so we're going to see more and more deployed on the internal to servers model. The cost economics are just too compelling, and now that you've got the capability and the reliability and the availability that you need in these models, it becomes very attractive for people. Okay, so I basically have talked about this, and I know we're short on time, so what I'd like to do is I want to go ahead and turn it back over to Chris, and thank you for your attention today and time.
Thank you, Eric. So as Eric has shown, software-defined has great implications for our business. They're broad-ranging, and they help make business more agile today. It's critical that we all get on board to figure out how all that stuff impacts our businesses. To talk about software-defined, I'd like to introduce now Tarkan Maynard, CEO and Chairman at NextGeneration, a person who's extremely passionate about this particular topic.
Thank you.
Thank you, buddy. Cheers.
Thank you, Chris, thank you, Eric. And thank you, Eric, for coming all the way down. You're in San Francisco, all the way, different time zone. I know you're jet lagged. I'm also coming down all the way from San Francisco, and I'm really happy to have this conversation, fireside chat. It's super warm here, very hot. Chris, I think you mentioned as well, this session is also live video streamed and audio streamed to many folks from the West Coast to East Coast. We want to welcome also our folks on the camera. Hi all, who are joining us via the web. So it's all web streamed, and the session is going to be throughout the day. It's going to be available on the ScaleMatrix website as well. So glad to be here. I'm CEO of NextGeneration. Maybe I should move the next slide. This is who we are, the orange guys. But before starting talking about NextGeneration, just recap what Eric and Chris talked about. And before that, I would like to ask you a quick question. How many of you in the room, this is important, are in line of business? Non-IT people, line of business, business people. About 5 people. And how many of you are in IT, in technology? Great. And the rest of the 250 people are just showed up? All right. We should make sure we charge them for valet. Exactly. So, glad to have you here. First of all, it's super impressive. Thank you for ScaleMatrix, to Mark Ortenzi, Chris Orlando and team to welcoming us here. There are a lot of tech vendors here, I know, from the East Coast, West Coast, some of the logos you see around here, and vendors sponsoring this event. We want to thank them, obviously. We, as NextGeneration, being one. Going back to Eric's discussion around software defined, just was at JP Morgan conference, tech conference in San Francisco yesterday, and when they got up there, we had the CEO, Jamie Dimon, joined us from New York. And he had one slide, and first slide said, everything is going to cloud. And he said, as a bank, we are not any longer a bank, we are a cloud business. Everything we do is now all about technology, not for technology's sake, but technology for better customer service. And the only way we can deliver this as a company is through the cloud. This is a $150 billion company with 300,000 employees. So to do cloud, you just don't have to be a big company or small company. You just have to run a business and you have to give a better service. And the only way to do that today is with these new type of cloud technologies. And building your own data center, maintaining that data center is now the old school. That is the reason what ScaleMatrix does, and companies like ScaleMatrix do, is super, super important for the business and for our economy, to be frank. I'm red-eyeing from here tonight to Detroit. We're meeting with GM, Ford, and Chrysler. All 3 companies are going through transformation and removing their data centers they built in the last 45 years. They have to go to a public cloud service, yes, with some of the technology they purchased in the past, but they have to partner with companies like ScaleMatrix, deliver a solution, a service to their customers, dealers, and supply chain suppliers like Visteon and Delphi and all those big suppliers through the cloud. Otherwise, they cannot keep up with the low-cost labor economies of Asia Pacific. There's no way. And we're talking to these people at CEO level. In the past, when we sold technology, we talked to the IT people like you. But now the CEO and CFO involved in that conversation. That is the reason what ScaleMatrix do, what ScaleMatrix type of companies do is so special. My Britney Spears microphone is coming down. Now I look like a Madonna. I'm older a little bit. I think I'm more Madonna. Some of the girls are laughing. I don't have the muscles. I'm not sure if you heard the last piece because the microphone was down. All these car manufacturers now move into that public cloud service themselves using some of the technologies they built and they integrate it with companies like EDS and others for the past 40, 50 years. When you look at the car manufacturing process as an example, almost 20 to 30% of the cost actually goes back and allocated to data center and the IT infrastructure. I just got back about a couple of weeks ago from Korea. Hyundai. Anybody drives Hyundai? Hyundai cars? Only one? You're lying. You're lying. I drove a Prius. I'm proud of it. And actually has an orange wrap-up on my company. Only one Hyundai driver in San Diego? You're killing me. Okay, one more. Thank you for the courage. Hyundai is a Korean car company, one of the fastest growing companies, and they built a new connected car cloud. Every car has about 1,200 sensors in the car, from the brake pads to steering wheel, even your butt, the seats. Every part of the car has an online diagnostic device. Just gets diagnostics and brings to a server behind the stereo. A white box server that you never heard the brand of. And 4 million cars around the world sending the data of the driver of every single part on that car to a connected car cloud around 17 data centers around the world. We deployed in the last 12 months more than 4 petabytes of storage for that big data implementation. When we met the CEO a couple of weeks ago, he says, since the inception of our company in World War II, in Korea, we generated about 12 petabytes of storage. In last 12 months, we created 4 petabytes of storage. Just to give you an idea. In the old school ways of doing data centers, buying expensive hardware, expensive software, expensive integration solutions from service providers, and building data centers to run your business, that model cannot sustain itself any longer. Because the pace of data is growing at a pace, at a velocity, you cannot keep up with dollars. Today, Eric kind of mentioned, we have about 7 zettabytes of data in our universe, as far as we know. Because we don't know life on other planets yet. We might have some data centers in Mars. There's some water. But today, as far as we know, 7 zettabytes of data. And by the way, this is IDC data. IDC data also says in the next 5 years, that number is going to reach about 50 zettabytes. Some of those theses did not include some of this big data, connected car clouds, what SpaceX does in Hawthorne, LA, what NSA does, what NASA does, what JAXA does not include all these new internet-connected devices, does not include the data that Nest thermostats in your home creates. The number of data, the capacity that we're gonna need in the next 5-6 years is gonna be beyond that. And guess what? Since you're IT folks, you promised me, you told the truth, 99% of this room is all IT folks. Guess what? The line of business budget for IT is also not going up, it's going down. That's the service, that's the data we're getting from our customers and analysts. Specifically on storage, CIOs are telling us their budgets are being cut by 2 to 5% every year. That is the reason this is so important. It's not only for the sandwiches and coffee and the booze and this beautiful data center. What's happening here is the real deal. And we see this from our customers all the time. As Nexenta, we just do software-defined storage. Just one layer in your data center. Compute, network, storage. The reason we talk about software-defined storage all the time, and it came up in Eric's presentation, is because 60 to 70% of all cost in your data center goes to the data storage in some shape or form. Even if you close down and shut down your business, you will still create more data. Some companies, even if they don't deploy new applications or servers or networking equipment, they still create more data. As we sit here, our iPhones and cell phones and smartphones are creating more data. The log data. Have you seen the Democratic debate, the presidential debate? You remember Bernie Sanders says to Hillary, I'm sick and tired of your goddamn emails? We're not. We run most of the Department of State data as Nexenta on Dell and Supermicro servers. We have more than 30 petabytes a year being created on emails. Does not include Hillary's personal server. With that, it's maybe another petabyte a year. Joking aside, if Department of State tried to do this themselves, buying gear, buying software, integration services, they would not be able to deal with that budget because their budget is being cut today. And that's going to get even worse as we move forward. 2016 and 2017 from an economic perspective, are not going to be great years. There's huge budget deficits around the world. China is obviously, from an economic perspective, is slowing down. Our exports are going to slow down. The consumption, domestic consumption, is going to be the only way to grow your businesses. Guess what? A lot of people are going to cut budgets. And the only way we can be successful as businesses, we have to get more efficient. And cloud technologies are the only way to do that. Even as a company as Nexenta, we have about 300 employees. We don't run our own data center. We do colo work with Scale Matrix. We run our systems with Scale Matrix. Also, Scale Matrix is our partner to deliver our technology as a service. Because there's no way, as a tech company, we're going to go out and sell support servers individually in every data center all the time. Do we do that today? Of course. Because private clouds and data centers are not going to go away overnight. But clearly, hybrid cloud is the winner, and clearly, public cloud services are going to gain more momentum. If people tell you, oh, it's security and privacy, and because of this, I'm never going to do that, guys, we do cloud services, cloud businesses with our bank all day long. How many have you been to a safe box in your bank in the last year? We do all online banking. So some of these are all red herring. At the end of the day, this is a reality. That is the reason as Nexenta, we sponsor this event. We are here with Scale Matrix because we want to talk to you, customers like you, not directly, through a service provider who can deliver that service to you cost effectively, rather than we're selling our software to you individually all the time. Because there is no way to deal with that budget. Even though software-defined storage, software-defined data center solutions are the cheapest way to go about it. Last year, the entire IT industry was about $3 trillion around the world. Another IDC number. I need to pay you royalties after this. $3 trillion with a T. Of that, half, $1.5 trillion were all services. The rest, $1.5 trillion, half software, half hardware. And guess what? The software and hardware piece is going to shrink. Services is going to take over. And that's the reason we're seeing a massive consolidation in the IT industry. Dell folks are here, my alma mater. Dell just acquired EMC, as you heard, big tectonic shift, but this is just the beginning. We're going to see more consolidation because all these large system vendors have to find ways to cut cost, scale higher, and deliver a service model to customers, people like you. So on that note, I don't have many slides. Let's just share with you is, we are all about #BetterTogether with you as customers and partners, but do it with partners like Scale Matrix. Deliver what we do as a service, as cost-effectively as possible. In that context, let me give you one other number just to get the idea with numbers. Last point. Last year, storage industry sold to customers like you $9 billion worth of new storage. Storage hardware systems. $9 billion. Incremental new capacity. I'm not talking about the maintenance support you pay of the capacity you paid before. This is 2014 new capacity hardware system you buy from companies like Hitachi, EMC, NetApp, and others. $9 billion. And it was new capacity of 9 exabytes. If you want to do a calculation and find out how much you paid per terabyte, let me make it easy for you. It's about $1,000. As users, including companies like us and Scale Matrix, if you use a hardware system, you paid $1,000 per terabyte for your storage if you bought directly from these companies and ran it in your data center. $1,000. You're still sitting. You're not crying or you're not screaming. Because if you go to an Apple store, I can sell you 1 terabyte Western Digital drive for $29.99 today. Did someone say there is a little bit of mafia going on? We're paying as an industry $970 additional premium when we buy into our private clouds. I'm a customer too, I'm a CEO. I work with my CFO all day long. How we're going to cut our own IT cost? We have to treat our customers the same way. There is no way this kind of a model can sustain itself. That is the reason EMC and type of companies like that have to find a way to move the service model. That's why this massive consolidation. And we believe a lot of mid-sized customers, SMB customers, even large customers like GM, Ford, Visteon, Department of State, Hyundai, obviously we have only 2 Hyundai cars in the parking lot, I'm going to check that later, have to go to a cloud service. There is no other way. So on that note, as Benjamin Franklin said, there are 3 types of people around the world. First, those who are immovable, you cannot move them. They are super rigid. Second, people who are movable, you just need to talk to them a lot to move them. And the last one, those folks who just move. I'm assuming Scale Matrix is that guy and that company, and we'd like to move with you, and I hope you guys move with us into this new era, to that new software-defined commodity hardware services model through your hybrid clouds. So thank you for being here, and look forward to talking to you later on.
Thank you.
Thank you.
Thank you. Tarkan, thank you, bud.